Hello everyone. Today I will be presenting my final project, which is deepfake audio detection with time-delayed neural network, and I'll be calling it TDNN from now on. So deepfake audios can be used for various purposes, including fraud, impersonation, and spreading disinformation. So of course we would like to be able to tell whether an audio is deepfake or not. And existing studies has been using CNN-based and LCMs as the classifier with the corresponding features. The state-of-the-art use EOTP and FCC features and use a deep bidirectional LCM to do the classification. And I propose using a TDNN for two reasons: because it's faster to train than an LCM, and it also considers time feature, which might not be as good as LCM, but still. And I would like to see if TDNN achieves relatively or comparable results compared to CNN, in which people have been using ResNet or LCM. And this is my method. I first use the Caldi library to extract the MSCC feature from the audio files. And the audio files have different lengths in the data set, so the extracted features will have different numbers for each file. So I apply a fixed size window to make sure the input size is consistent. Then I pass the data into the TDNN implemented with PyTorch and do the classification with the probability. Sorry. And this is the result. It's worth noting that this is the distribution of the numbers of the MFCC features from each file. Most of them lies between 200 to 400. So for now I use a window size with 100 and 200, and I use two TDN models. One is a simple TDN I built. The second is called the factorized TDN, which is also used in Caldi. And this is the result. The metrics I use are accuracy and TDCF. TDCF is a metric used in the challenge where they consider the score. In my case, the score is the probability of each audio files being spoofed or not. And the lower, the better. So we can see the state-of-the-art, which I just mentioned, they achieve 0.008 TDCF, and they didn't use the accuracy metrics, but this is from other studies. So we can see that the TDN did work. We can see from the accuracy it's doing a decent job, but unfortunately it doesn't beat LCM. And the probability, which is the score, could use a little more tuning. So how to understand this is the TDN has been classifying the audio files mostly currently, but not with high confidence.